Hello everyone, we are live again with the Bootcamp 2020. Today we are going to cover Amazon AWS DynamoDB and then the construct of a cloud construct. So let's start with the DynamoDB. Huma, please, can you
Yeah,
give us introduction and the move further?
yeah. So today's topic is DynamoDB Stream. DynamoDB Stream. What are DynamoDB Stream? Uh, when enabled, if your table is enabled with Dynamo Stream, whenever there is modification in your table, like you add a data, you delete it or update it, you get stream, a log, transitional log. Okay. So for our example today, we have integrated that with Lambda. So whenever there is a change in table, we get an event inside the Lambda and we can use it. Now, a simple use case which can come in mind is like whenever there's a change in DynamoDB table, we can trigger an event based off that change. Another use case for that can be if your data was previously or in any case you have migrated from a relational database to a DynamoDB database. You in the DynamoDB database do not get any relation among the tables. You can use these logs to create relation among the tables. Second use case can be when your database is like huge and you have thousands of entries. Doing search queries like getting the max or min will like affect the optimization of your data. So what you can do, you can extract few records out of that data, the table, main table, and insert it in some another table so that you can run those kind of queries on another table and do not affect your main table. Let me share my screen. There are two things in DynamoDB data stream. One is it holds the record for only 24 seconds, 24 hours. Beyond that, it destroys the data, the log, the transition log. Second is like it's time streamed, it's time sequenced. Let me share the screen. Okay. Just a simple use case for your DynamoDB stream could be as soon as a change occurs in your DynamoDB stream generates records. Each record is like each item modified in your table. That actually triggers your Lambda, and then you can proceed with whatever computation you want to do. In this case, you are actually triggering one Lambda, and that Lambda is actually putting your record in Elasticsearch service. In this case, you have actually attached three Lambda. So let's say when I have a new user in my DynamoDB table, using those log streams, I can send a new SMS or SQS to that particular user. So I can use these logs without affecting my optimization. Let me show the code. This is the stack code. I hope that it is enough zoomed.
Yeah, I think
Yes, it's
it's
enough.
fine.
Do one more. Yes.
Okay. Okay. So the very first thing in this stack is I have an orders table with partition key ID. The second thing is I have enabled stream. With the stream, I get four options. What do I want in my stream logs? I have four options. Either can I have new image. Now this will be like new record I have added in my table. Either can I have old image, the previous old image of that record if I have that. Or either can I have old and new image both. And the fourth option is only having the key of that data which is actually modified. Now, next thing we have is a Lambda. I'll come to what this Lambda is actually doing. And then here we have actually add an event source to this Lambda. Now this portion here actually defines how my Lambda will behave once the log streams are there. The very first thing is starting position. Starting position have two options. Either I can do latest, or either I can do horizon. Again, I'm not sure exact the name. Okay. What latest does is as soon as I connected my Lambda to my table, whatever latest logs are there, I want those logs. With the other option, what I can do is since DynamoDB stream holds the data for 24 hours, the second option allows me to get all those previous records before I actually attach this Lambda to the stream. batch size. It actually, what does batch size does, I have limit from 1 till 1000. Is it actually buffers those records. If I have 5 records in my data stream, then only this function will run. Retry attempts, if in any case it fails to fetch the record, what should I do? Either I can add it direct to the SQS queue, or I can do retries. In this case, I have configured 10 retries. Once it's done with its retries, and even then it failed, on failure, it will add in on SQS, which is actually defined here, dead letter queue, so that I can do whatever I want to do with that. Now, coming to my Lambda. Here this Lambda is actually doing nothing but consoling the response, which will be like, as I said, I have connected this Lambda with DynamoDB Stream, so the records will be coming in the event. This event will have an object record, and my batch size is 5, so I can have more than one record. I am iterating over those records, and I am actually simply outputting that record. Okay, now I have actually deployed the stack already. This is my table, and I have 2 records in my table. This is my Lambda, and what I have done is I've actually triggered it, and this is what my record looks like. I have an ID of the record which actually changed, and the new image, because in my case I have deployed the stack with new image configuration here. So what I mentioned here is with the streams that I only want new image. So this log is actually showing me only the new image. Done, sir.
Okay.
So the best advantage, I just wanted to add one thing. The best advantage of using the DynamoDB stream is that, as Huma also mentioned, that instead of calling a data every time, or you calling a request, sending a request to the database every time, what will happen is you can listen to a table, and if any particular change or any information is updated to that database, it will send the data directly to you. And the advantage of using the stream is it will, as Huma mentioned, it will stay 24 hours inside the stream, so you can attach different uh, listeners to it, and then you can read data, and then you do whatever you wanted to do with this particular data. So the streaming is quite beneficial when you wanted to you want data to be travel continuously from the target to the source, or source to the target.
One
Yes,
more
Faris,
thing,
please.
actually, let me add that
Yes.
this also helps in data replication. For example, if you have 2 different tables in different regions, you can replicate the data which you actually do not get out of the box with DynamoDB, but you get that with other relational databases. And one more thing, I just read an article that with DynamoDB Stream and Lambda, it doesn't cost you any extra. So it's useful for doing queries for cost optimization as well.
Yes, and only the call of a Lambda will cost you, but we have a 1 million calls free. Yes, Faris, please.
Okay, sure. Okay, thank you so much, Huma. So before moving on to the next step, that is our, I think, cloud constructs, I'll just quickly revise DynamoDB stream. So basically, you can actually attach a stream to your DynamoDB table. And so whenever there would be a change in the data of your DynamoDB table, data would be sent to stream, and then you can, on the other end, you can connect a Lambda function with the stream. And so whenever there would be a change in the data of the DynamoDB table, the stream would send the data to the Lambda function and invoke it, and that changed data would be available in the event of the Lambda function. So yeah, it'd be quite useful. So there's one particular question that I've been asked a lot about DynamoDB streams regarding Project 15, that can you calculate a multi-tenant matrix using DynamoDB streams? Well, the answer is you can, but only for the write operations, because if user does some kind of read operation on the DynamoDB table, then nothing would be changed in the table and nothing would be available in the stream. So you can only do it for the write operations, not for the read operations. So this is one question that I've been asked a lot regarding Project 15. If anyone doesn't understand what I'm talking about, then okay, because it's just a common question regarding Project 15. Anyways, moving on to the next step. Sharing my screen. So our next step is cloud constructs, basically how to create your own constructs. So before going through the code, I would actually like to discuss some basics. And these are very important basics because most of us don't even realize what is the structure of our CDK project. We just start coding on the file that is in the lib folder, right? So let me just quickly explain you like what is the structure of our CDK project and how do we create constructs and how are they actually what do you call it placed in the structure of your project. So to explain that, I've actually made a very simple diagram. This diagram is basically the entire structure of your CDK project. And I think most of us don't even know it because most of the thing is done by because most of these nodes are created by the CDK init command. So basically, the first thing that you can actually see is that the structure is kind of a tree. It's like a tree structure. It's branched out. It's a tree structure. First thing that you need to understand about the tree structure is that tree structures can only have one root node. So each one of these boxes is a node, and the tree structure can only have one root node. Root node means the top level node. So in this case, the root node is the app node. So I'll come to what is app later. Just take my word for now that app is the root node of your tree structure of your CDK project. So every CDK project has this root node, and the root node has to be the app instance. So and the second, so the first thing is that every tree structure has a root node. The second important thing to understand is that every node is defined within the scope of another node, except for the root node. So except for the root node, every node is defined within the scope of another node. So what do I mean by that? So if you can see over here, this is our node defined within the scope of the app.
I guess Waris has struck, or
No, actually, virus has froze.
okay, let me try.
Is defined as now.
Okay.
Let's actually go through this entire diagram.
Okay, you are back now. No problem. Yes,
Yeah,
now
okay.
you just froze for a minute.
Oh, okay. So let me just repeat it. So we're saying that every node is defined within the scope of another node, except for the root node. So in this case, the stack node is defined within the scope of the app node. And if we go here, all these three constructs are defined within the scope of the stack node. And likewise over here, these two constructs are defined within the scope of this construct, and this construct is defined within the scope of this construct. So the two important things to understand. The first one was that every tree structure has a node, root node, that is going to be every node is defined within the scope of another node except for the root node. So if I go through the diagram line by line from top. So first of all, we have an app that is our root node. Then the immediate child of app is always called stack. Now there's not much difference between stack and construct except for that stack is the immediate child of app. And in that stack, we define our constructs. And this is where we usually write our code. So we usually write our code in the scope of the stack, the file that is in the lib folder. So this might be your Lambda function, L2 construct of your Lambda function. This might be your DynamoDB table. This might be your app sync or whatever, right? So this is where you normally write your code. And you should know that everything that we're normally writing is in the scope of the stack. And it is called construct. So as I said before, there is not much difference between construct and stack, except for stack is defined, is the immediate child of app. and stack can have many different constructs. Now, the important thing is that even constructs can have more constructs in them. Like in the scope of construct, I can define more constructs. Now, this is an important this is an interesting concept. So yeah, I think everyone has understood this diagram. So let me move on. So this is just some theory about the diagram that I showed you. So app is the root of the tree. The entire tree is within the scope of app, just like we used to have an app element in the React project, right? Yeah. So this is a very important step because basically stack is the immediate child of app, but everything else is also inside the scope of the app. Like the immediate child is stack, but everything else is inside the stack. So therefore, everything else is also inside the scope of the app. So app has everything. It has access to every node because it's the root node. So you can not have more than one root node, but you can have more than one stacks. I've never created a project. I've never created more than one stacks in my project. I think maybe for complex projects, you can have more than one stack. So the second point is stacks are created directly within the scope of the app that we just saw. Stacks can have multiple constructs defined within their scope. So a stack can have multiple constructs within its scope. Constructs can also have other constructs defined in their scope. And this what we saw over here. This construct has two more constructs. This has one. This has none. Now this is some extra information like we've been using L2 constructs. So L2 constructs basically, so whenever you create a Lambda function using L2 construct, it is basically creating some L1 constructs behind the scenes. So this means that whenever you create an instance of a Lambda function using L2 construct, it is basically creating some L1 constructs within the scope of that L2 construct. Now this might sound confusing, but that's how it is. Let me try to explain it with the diagram. So let's say that this was my this is where I created my Lambda function using L2 construct. So this L2 construct would create some more L1 constructs. Let's say created two more L1 constructs, and these two L1 constructs would be in the scope of my L2 construct, my L2 construct of Lambda function. So this is also very important to understand that L2 constructs always are always made using L1 constructs. So whenever you get an instance of L2 construct, you're also creating L1 constructs that are in the scope of your L2 construct. So yeah, that's it for the theory. Let me actually go to the documentation. So you can see over here, I just explained to you. So
I think
on the top level, you have.
I think there's a one point which we have discussed at the very start of our CDK classes, that every what you say, every service has a L1 construct in our CDK, but L2 construct is based upon L1 construct. So L1 constructs are one-to-one mapping with the CDK AWS services. L2 construct are based on L1 construct. So you have S3 bucket. So you have a S3 buckets construct. Then you wanted to add some other features or some default property. So they have created the L2 construct, and if you create L2 construct for the Lambda, so it will just do some default what you say, default initialization of policy assignment and lot other things. So that's why, and we have discussed it in initial classes. Or
Yeah. So basically, if you create Lambda function using L1 construct, it would be much longer. L2 constructs are just easier to use. So most of the things have been initialized by L2 constructs. So we don't have to do them. So this is the diagram which we also saw in the beginning of these classes. So as I showed you, at the top level and the root level, you have application, CDK app, and in that we have a stack. You can see this inner box is your stack, and within that stack we have constructs. Now constructs can have more constructs within them. This is exactly the diagram that I showed you. Yeah. So let's move towards the code. So I'm going to make a new project. I'm not going to go through the example that is in the repository, although it's a very good example, but just to explain it better, I'm going to start from scratch. Maybe if we have time, I'll also go through that example. So what was the command? Just make a new folder first. just install the dependencies as well. So I'm creating the project from scratch so that I can show you a few things. So when I ran CDK init, it made this folder, and in this bin, if I go into this bin folder, you can see it. Let me just zoom it in. It automatically created an instance of app for us. And what is this app? This is our root node. Everything is going to be inside this app. So we don't notice it because it is created by default by the CDK init command. And then you can see it created a stack in the within the scope of the app. So if you remember properly, that the first parameter is always the scope of every construct. So even for the stack, that is, we have divided, and we have, so you can see that the scope of this stack that we just initialized is this app. And where is the class for this instance? That is in the lib file where we usually do our code. But it's important to understand that whatever we are usually writing over here is in the scope of this stack. And that stack, it was created in the scope of the app. And you can also add some props over here if you want to. They're optional, but like region, you can add your region if you want to. I'm just going to delete it for now. As I said before, there's not much difference between a construct and a stack. Stack is just the immediate file of the app. If you come here, so it has been installed. Let's create a Lambda function first. Let's change this to app. Okay. Let's first create a Lambda function. Lambda function. So the first parameter is this. Now if I write this, okay, I'm saying that I want to create my Lambda function within the scope of the stack. This is important to understand. The Lambda function is being created. This is where I'm writing my Lambda function. The Lambda function is being created in this scope of the stack, and the stack was created in the scope of the app. This is important to understand. That's why I'm writing this over here, because this class is the scope of the stack, and then I have to write an ID. Then required props. So runtime. And then what else? Code. I'm just going to write an inline code. We don't usually do that. We import it from another file. But you can also write the code as a string using this method. It should be export. No. I'm not sure if I wrote it right, but yeah, it is just a function that is logging the event. And then what else is there? Is there a handler? The handler would be index. So whenever you write code like this, inline code, the handler would always be indexed. So we have just created a normal simple Lambda function. Now what we can do is we can actually have a look at the scope of Lambda function, like what's the scope of the Lambda function. To do that, you can actually write Lambda function dot node dot scope. This will actually give me scope. And what is this Lambda function? We already know that it is being created inside the stack. So the scope would be this. Scope would be this. So let's see. You have to run npm run build ctk send. So you don't have to deploy check your logs. You can just write csend. You can see it is saying the scope of my Lambda function is test stack, and that is this this instance. Yep. So my construct is basically is defined in the scope of my stack. But you can see that so this is the scope of my Lambda function. Let's have a look at the scope of the stack. So if I just write this .node.scope, now I'm asking for the scope of this stack, this instance. So it's going to be the app, because this was initialized in the scope of the app. So let's see what is the return. I'm just trying to explain you the hierarchy of the structure of the project. Otherwise, you would not understand how to create constructs. So you can see now it's saying app. The scope of our stack is app. The scope of our Lambda function is the stack. Now you can also see the children. Now I said that if you create a Lambda function using L2 construct, it would also create some L1 constructs, and those L1 constructs would be the children of my L2 construct. So as I showed you here, so if I say that if I created a Lambda function using L2 construct, it would also create some L1 constructs, which would be in the scope of my L2 construct. And so therefore the L1 constructs would be children of my construct. So these are children of stack. Stack is a child of app. So this is what you call children or child. So if I write lambda node.children, I should be the L1 construct that it makes. I've never tried running this command. Let's see what happens. Okay, so there's a lot of information. So okay, so number one, it created a role. We all know that whenever we create a Lambda function using L2 construct, it also creates a role for that Lambda function. So this is how it creates a role. On the back end, it's running a command for role, for creating a role. And then the second thing is the L1 construct of Lambda function that is called CFN function. Let's see if it created anything else. No, that's it. So so this means that whenever you run your L2 construct of Lambda function, it creates a role and L1 construct of Lambda function and then combines them together. Now you can also have a look at the children of this stack. So there's only one child in this stack, that is this Lambda function. So let's see if it shows that. So yeah, there's only it showed a function. Did it show anything else? No. So don't worry about all this other stuff. It's just the properties and other stuff of this construct. And yeah, it's a bit advanced. So it actually shows you the properties like function name, ARN, and everything else. But yeah, it says that it only has one child that type function. We know that in this function we have two more L1 constructs that we just saw. So this is how your CDK project is structured. This is what is happening when you create a L2 construct. Now let's see how. So right now we're using L2 constructs that were provided to us by AWS. Now let's try and create our own construct. Now to do that, you can actually put it anywhere you want to, but I'm just going to create a new folder called constructs. In this construct, I'm going to write my construct. Yes. Now construct has to be a class. Let me actually just copy it from here. This entire thing would almost be the same. Running with my construct, it's going to be now it's going to be construct. And previously we made a stack over here, that's why it's stack, but now it's going to be construct. The scope would be stack because we're going to initialize it in this stack. I'm going to initialize it in over here. It's going to be stack. And then ID, I can remove props for now. And I forgot to import CDK. Okay. Now, what do I want inside? I can have anything in this concept. Let's make another Lambda function. I'm going to call the same thing over here. And I can also have function. I hope everyone is understanding what I'm doing. I'm just creating a class, and I'm initializing a Lambda function in here. And it's extending from CDK construct because it has to do that, and because it's a construct, right? This is a class provided by AWS, and because we are extending it, we have to call this super and pass our scope and ID in it. Okay, now let's also create a prop. We can also do that. So, and I'm gonna create a type for the props. So we can actually pass function name. And in function name, we can pass it from the props. Right. Now let's see how can we use this inside in our stack. So this is how you create a construct. This is how AWS must have created. This is how AWS must have created their L2 constructs. So let's see how can we use them in our main stack. Now we want to use that construct in our main stack. Right now we're only using an L2 construct that was provided to us by AWS. Now we have created our own stack. Now let's import it first, just like we imported Lambda. So import. So it's in constructs. My construct. You can initialize it in exactly the same way because the parameters are same for all the constructs. So it's going to be my construct. My construct. And the first thing is the scope. Okay, it's asking the first thing it's asking for is the scope. Now this has to be the same for all the constructs. These parameters. So in my case it is looking for a type stack, and we are already in this stack, so I'm just going to pass this, and then it's asking for an ID, and then there's one parameter that we need to pass that is called function name. So you can see I created my own stack and then call it inside my. So I created my own construct and then call it inside the stack. Now we have two constructs over here. So if I go back to the diagram, we have a stack, and the first construct that I made was using the L2 construct of AWS, and the second construct was my custom construct. And in this custom construct, I have another Lambda function that is using that I made using L2 construct, right? So okay. So what we can do is we can again check for the children. Now yeah, let's check for children of this construct that I just made. What should have? It should only have lambda function. Hello, can you guys hear me?
Yes.
Yes.
So you can see in our custom construct, there's only one child, that is our lambda function. Well, I can also try and add a few more things. Let's add something different. Like, okay, let's add cognito. So it's really hard to initialize a cognito user pool. So I'm just gonna copy. Oh, I have to install it as well. And now my construct has two children. One is lambda function and one is user pool. Let's see if that is reflected in the logs. And it's important. Let me just quickly run the logs. Now you can see I have one function, and there should be a user pool as well. Yep. So there's one user pool and one function. Now we have two children in our custom construct. So that's how you create a custom construct. But you need to realize that if I look at the children of this stack, I have one lambda function and this construct. Immediate children of this stack wouldn't have the lambda function that is inside my L2 construct and the user pool that is inside my inside my custom construct. They would not be the immediate children of the immediate would be this lambda and my const. So this is important to understand the hierarchy. Now, okay, I think I should actually make a diagram for this example that I showed you so that you can understand it. I know it can be confusing. So we have an app, we have a stack, and here we have a lambda, L2 lambda function. And L2 lambda created a role L1 and lambda L1. And then we have our custom construct. And that we have this entire thing inside this. Oh. And then we also have user pool L2. And the user pool would also have some L1 constructs. This is how our diagram would look like. I hope everyone has understood it properly, but then it can be confusing. Anyways, so moving on. So there are a few commands that I want to share with you. So the first command is Let me show you. So basically, it's given us some command we can use. Now, this command, what it does is that it says that I'm going to add tags to all the resources or all the constructs of a particular scope. In this case, I'm passing this, which means which means that put a tag to all the constructs that are in the scope of stack. Which tag? It goes in the key value pair. So this is the key, this is the value. So and here does not only mean immediate children, it means everything inside the scope of the stack. So as I told you before, the immediate children of this stack are only these two. But this command actually says that I'm going to add tag to everything that is inside the stack scope. So that is going to be the L2 construct, L1 construct, L2 construct, everything inside my custom construct, and everything inside the L2 constructs of my custom construct. So everything within the scope of the stack, not only the immediate children. So this is what this command does. So you can actually very easily add tags to all the resources in a scope. So if I put it inside my custom construct, would mean that the tag will only be attached to everything that is inside my custom construct, and there would not be any tags on this construct that is in this scope of the stack. So I've placed that tags method inside my custom construct. So only the resources that are inside my custom construct would be tagged. So this is the first command that I wanted to show you. Second is annotations. This is also a very useful command. So whenever you want to generate an error or add some kind of info or add some kind of warning when the person is synthesizing your CDK project, you can show it through this command. So let's add info. If I run CDK synth, it should show me over here. Now the info is shown in white color because it's not alarming. It's just info. So you can see it's saying that info at stack. Why does it say that? Because in scope I pass the scope of my test stack, and it's also showing the message. Now if I move it to my construct, let's see what happens now. Why is it showing? Wait. Oh, I forgot to say that. Let's do it again. I have only placed the annotation command in my custom construct. So let's see, what does it show? So it's saying info at teststack/myconst. And what is myconst? Myconst is my custom construct that I made inside my stack. So it also shows you that where is the information coming from. Now, this was the info. You can also show warnings through annotation. So you have to check to add warning. Yes. The warning is shown in yellow so that the person can see it. So you can see over here, it's showing the place, the scope from which the warning was generated, and also the message. And then there's third thing called error. Now, error won't let you compile the program. So it will just give you an error that we cannot compile or create a CloudFormation file for you because this is the error. And you would not usually put this like over here, but you would put it in some kind of like if else logic. You would check for something, and if something's wrong, then you would generate an error. But for now, let's just put it over here. And the errors are shown in red color. So see, it did not even create the CloudFormation file for us. Did not even synthesize it. It just gave us error. That, okay, you need to fix this. So this is annotations. So do we have time? Should I go for the aspect?
Yes, we have time.
Okay. Now there's one more command that is quite advanced. So, but I'm just going to show you how to use it. It can be very, very powerful, and it's called aspects. And for that, I'm going to come into my custom console. Oh, let's just stay in the stack. So, cdk dot aspects. Again, this. What this command does is that it lets you loop over all the constructs or resources in your scope. And by loop, I mean that you actually get that construct or get that resource and add some properties to it. Now this over here actually takes a class that implements iAspect class that is provided by AWS. So this might be confusing for some of you, but let me just do it. And then implements. So I can actually. I can see if I click over here, it says the property wizard is missing in map. Now, because this is a abstract class, we have to actually define the required properties. So I'll go over here. Now the error is gone. Now basically you have to call a class over here that that implements cdk.iAspect, and it should also implement this with a function. Now this is quite advanced. Even I don't have much knowledge about it, but yeah, if I try to explain it, you guys would get confused. The main idea is that before synthesizing your project, you can actually go through everything inside this scope, whatever you put over here, like each and everything, not just immediate, each and everything. And then you can perform some action on them. I'll show you how. So I'm calling this class over here that I just made, and it should implement the aspect, and it should also implement this function. And in this function, we can actually check what kind of. So in the node, you would get constructs one by one or nodes one by one. So you can see right away we have passed this scope. In this scope, the immediate children are only 2, but within these immediate children, there are more children. So we are going to get each and everything inside this node, not just immediate children. And we know that our we have 2 lambda functions inside this entire thing. One lambda function is the immediate child. The other lambda function is inside the other child, is inside our custom construct. So if node is instance of divided instance of lambda dot function, checking that if what it's going to do is going to go through all the children of this scope, and whenever it will find a child that is instance of a lambda function, and we have one over here and one is in our custom construct, I'm going to do something. Whenever I'll find a a node that is of the function type. So I can just console log found a Lambda. Yep. I'm just logging over here, but you can actually do whatever you want to. Like you can add layers to it. Yep. And or you can, I don't know, change something. Look at its children. You can do anything with it, like literally anything. And this can be very powerful. And this runs actually before synthesizing your the CDK project. So this can be very powerful. Like if before synthesizing you want to change something in the children of a particular scope, you can do this. So for now, I'm just going to log on. So we should this should be printed 2 times because we have 2 Lambda functions inside this scope. One is the immediate file, and one is inside our custom construct. So let's see what happens. So you see, we got. Sorry.
Can I ask a question?
Yep.
If we have a running stack and you are making up another stack with these configurations, can it modify the running stack?
What do you mean by running stack?
One stack is already deployed, and another stack is actually calling some nodes or children of already running stack.
No, this only changes the CloudFormation file. This does not it does not have to do anything with the thing that is already deployed. Are you getting it? So this only changes the CloudFormation in your local machine. It has nothing to do with whatever is deployed. So Zeeshan, can you explain it better? Like, I'm not sure how to explain it.
Basically, what happened is whenever, even if you deploy a stack, and then after deployment, if you made few changes, let's say you add a single lambda to your existing stack, so you are actually updating your CloudFormation. So what it will do is it will add another lambda to your existing CloudFormation. So the question, Huma's question was related to that. She was saying that somehow a stack is already deployed, but that definitely that stack will be part of your code, and then you will be using another stack which might be updating. So actually you are updating the existing stack, so it just add few more elements. If let's say your first stack had a lambda function, it was already deployed, and your another stack is adding some policy to that lambda function, it will just update that formation. It will actually update the your formation and updates the actual lambda over the AWS interface as well, or a cloud.
So it's just like updating your code manually.
Yes.
Yeah. So in this case, it logged found lambda 2 times because one is the immediate child and one is inside our custom construct. This is important to understand that it goes through everything that is inside the scope, not only the immediate children. So I think, yeah, that's it for today. This last thing was quite like, it's quite advanced, but you guys, I don't think you guys would ever use it, but if you want to, then you can. Like if you want to run a loop over all the resources in a scope, now you know how to. So yeah. And this piece of code is also available in the documentation. Like if you type AWS aspects documentation, you'll find this exact code. You can go through documentation as well. It explains it even. It explains it in more detail and how is it being like what kind of coding pattern is it using, and which is like an advanced topic that I don't want to discuss right now. So, anyways, yes, sir, I'm done with it. Yeah.
Thank you, Waris. It was quite great detailed explanation, and it was a bit of a roller coaster for most of us,
Yeah.
I guess. So basically what you guys need to understand is whenever you are working on an application, you are developing an application, it will not be the case that you will be writing a single 2 line or 10 line or 20 or 30 line of a code in your application. You will definitely have quite many of constructs or quite many of services in your application. If you are working a full-fledged AWS application, so you might have a Lambda function, you might have a DynamoDB, you will have AppSync, you will have EC2, you will have I'm forgetting a services, but there are 170 services in AWS. You will be creating too many services. So writing those all those constructs of service inside a single stack would be a huge mistake, because that means only a one person will be creating that stack, and if a 2 or 3 person are changing that single stack file, that will be also a problem while developing in a team, working in a team. So what you do generally is we use the reusability concept of an object oriented programming, or the programming as a whole. So what we do is we separate out the code in parts. To in case of our AWS CDK, what we do, for example, we'll write user management Lambda in a separate construct. So you will create a Lambda functions, but you will have a construct which says user management construct. And in that you will create all the Lambda function, and for the let's say AppSync for that constructs as well. Then you have a DynamoDB, you have 4 and 5 tables for the management of end users. So you need to create a DynamoDB tables. Then you have some stream management. Then you have some what you say. Uh, there are many services. When we start talking about the services, we start forgetting the names. Let's say you are wanted to manage user pools. So there'll be, if your single stack has 20 or 30 constructs, you should not write them all of them inside a single stack file. You should always use reusability concept and create your construct and separate out your construct based on requirement, based on usability. So as I said, all your user management Lambda construct will be inside one construct, and you will be using that construct in your main construct. As Varis showed, he created the construct and used the Lambda function, and then again created that construct inside main stack. So you always do that. So that's the reason why we create a custom construct as a one point. Plus it will help you when you are working in a team. You will have a 10, 20 or 30 people of team. It's 10, 20 or 30 is not a big number, but even then, if you have a 5 developer or even 2 developers, changing in a single same file will be a huge mistake. You will be always getting a conflict. So it's better to create separate constructs, work on a separate construct, and all those constructs will be getting called in the main stack. That's the main benefit. And when you are creating an application, it's always good for the when you use the concept of reusability. The another point which Waris covered related to the tags. So it's always good that, because in your stack, maybe your AWS account is in your organization's account, and there can be an uh, hundred of services being running. So as I said, we will be creating a separate construct and using those construct inside the main stack. So what I wanted to do is all the user related construct Lambda functions, I wanted to tag them, so that all those Lambda functions should have a separate tagging, so I can find all the construct related to user management. So that's why we have these what you say tagging. So cdk.tag, and you assign a construct, and all those child construct of that particular construct will have that particular tag. This is one example, and you can use many of them. Again, the annotation, as Waris explained in detail, that what you need to understand at this moment, we are creating a very simple construction stack. So you do not you are not imagining that why would I need to display the error. But when you will be working on a large application, you wanted to create a stack based on some conditions. So if the particular condition matches, add that particular Lambda or not. If the condition does not match, show an error. So do not allow to create a cloud formation file. So that's why you need to add the formation. And the aspect is a what you say. It's at this moment we are using AWS CDK construct directly. Slowly and gradually you will start seeing, and there are other companies will start developing their CDK constructs, their constructs based on CDK. So right now, as we use libraries, JavaScript libraries of other companies or other firms or other open source community, any other developer. We will be using in future, we will be using too many CDK constructs which were developed by any third party users. So what I wanted to do is, what you need to understand, AWS created a CDK construct and they have given all the Lambda function. Now a third party will come and what I'll say that I'll give you a construct. What it will do, it will create a Lambda, it will create a Dynamo, it will create a async and all those things. So you just have to create one construct and I will create all those constructs which you require. So it's useful for you to not create Dynamo, async, Lambda, all those things. You have to avoid writing too much of code. So I'll use one construct which will inside create many other constructs. Now, what I wanted to do is I'm using a third-party construct, but I want to add something or some logic or some policy or some role on all of the construct inside that third-party constructs. So then what you have is you have an aspect. What aspect do is it iterates, as Varis mentioned in quite detail, that aspects iterates all the child construct of a particular construct. So if you assign it on a stack, it will iterate the complete stack and all the child construct of that stack. So let's say I'm using an XYZ company's construct and they have 4 or 5 constructs inside it. I wanted to add a role policy on all the constructs into them. So then what I can do is I can create an aspect. Then I will have all the constructs, and what I can do is I will add the role to all the construct inside that stack. So that's how you can customize it. So what you are trying to do is from the outside you are changing the constructs which are hidden to you. So that's the simple explanation. It has many other and complex scenarios, but what you need to understand is creating a construct of a Lambda and AppSync, and there are 2 or 3 construct or 10 to 20 lines of code is not what you will be doing when you will be working a professional application. So when you will be working on a professional application, you will be have 20, 30, maybe 400-500 lines of code. Then you will need reusability. You need to create a construct, and if you will be using the third party construct and you want to modify them, then you will have the aspects as well. So I guess as Waris said, this is a bit of an advanced and complex to understand, but with time you will, whenever you will start using it quite frequently, you will keep absorbing how you will be use and how you will utilize those important aspects which are other than creating a construct. So hopefully this covers everything, and see you guys in the next class.
Okay, bye-bye.
Bye everyone.